So there are certain important things. Those will be deciding the accuracy, the output of the robot. Those are called the work envelope or the work envelope or work volume or a resolution of the work volume, repeatability and the accuracy. These are the four important terms will be defining them. Now here, all these I am not going to take in the beginning. I will be taking only the work volumes of the robot. Work volumes of the robot. Now, you take any robot, basically today you can find in the industries the robot which are engaged in the assembly operations, painting operations, welding operations, and they'll be just like a servant for the some of the automated mechanisms or machineries. Therein they'll be working like a worker, and they'll be used in the as a security guard. Okay, they'll be used as the entertainment toys. They'll be used as doctors for the teleoperated operations. Okay, and they'll be used in the underwater excavation. They'll be used in the space applications. Okay, you take anywhere. Okay, and there basically we have two types of robot. One is a mobile robot, one is an industrial robot. Please do not get confused. The mobile robot is one which will be having the wheels and the legs. That category will be different. I am talking about the industrial robot. The industrial robot, those will be engaged in any kind of jobs. Maybe it is a pick and place to any complex assembly operations as per the definition of RIA. Those robots will be falling into these four important categories. Those will be falling into four important categories. What are those four important categories? Cartesian, the physical structure outlook. If you look into, if you look into this one, the outlook will be showing you, the physical structure will be showing you how they are. So those will be these: Cartesian configuration robot, cylindrical configuration robot, polar configuration robot, or a SCARA or articulated robot. SCARA is selective compliance assembly robot arm. These are the four important physical configurations of the robot. Those you need to remember them. And why I have taken these, why I have taken in the similar sequence, you'll come to know that. The Cartesian I have taken first, the cylindrical I have taken next, polar I have taken next to that, then I have taken articulated next to that. Articulated is resembles to the human being arm. It is called as SCARA robot, selective compliance assembly robotic arm. Now the Cartesian robot, let me take. Why it is called as Cartesian robot? The work volume generated by these robots will be in the form of rectangular shape. You can look into this. You can look into this shape. This particular shape will be in the form of a rectangle. So that these are called rectangular configuration robot. Rectangular configuration robot. What is the work volume or workspace? Work volume of the robot. A simple example you can see. You just stand and stretch your hand. Turn around your body, and an imaginary cover or envelope which will be generated around your body, it will be work envelope. That means within this you can able to flexibly work. You cannot work. If you go to get into the hotel, the server will not be giving the food to other table. He will be giving it to your table, because you can able to stretch your hand and eat. That is your work volume. Within your work volume, you can able to flexibly work. In the similar way, the robot can able to flexibly work within its work volume. The work volume generated by these robots will be totally depend on their physical structure. Physical structure. So that the physical structure of the robot will be deciding the work volume, and based on this work volume, we are going to give the name Cartesian coordinate robot. You can see this robot, as the name indicates, the Cartesian, which will be can able to move linearly along the X, Y and the Z directions. The Cartesian coord robot can able to move linearly. There are two types of robot movements. One is a prismatic and then is a Rollywood. Prismatic is one which will be just like a telescope in action. It will be linear movement. Linear movement is a telescope in action. Okay, and a revolute joint is one which can able to revolve. That is called as a revolute joint. Okay, it is called as double joint. Now here, all the three joints, x direction movement, y direction movement, and the z direction movement should be linear. So that these are also called as LLL robot. L stands for linear. Okay, these robots have the coordinates x, y, z. The work volume generated by these robots will be in the form of rectangular shape. So that these are called the Cartesian coordinate robot. And all the links will have the linear movement, translation, prismatic. Okay, so that along the x direction it is linear, along the y direction it is linear, along the z direction it is linear. Okay, and where it can be used, since it is having only the linear joints, linear movement. Okay, linear manipulators. So there will be slightly restriction in getting done a complicated jobs. So that this will be used for only machine loading and unloading operations. Machine loading and machine unloading operations. And along with this, for all the robots, you can write pick and place. Pick and place is the basic work or basic design work which a robot has to perform. Okay, this is what I want to discuss. Then next, let me come to the cylindrical coordinate. Pardon? Anyone have doubt? Cylindrical coordinate robot. Cylindrical coordinate robot is having, please look here, the first one is Cartesian was LLL. Now LRL, linear, rotational, linear. Linear, rotational, linear. And the work volume generated by the cylindrical robot will be in the form of two concentric cylinders. So that it is called the cylindrical robot. The work volume or workspace of these cylindrical robot will be in the form of a cylinder. So that these are called cylindrical robots. And this is also called as LRL robot, linear, rotational, linear. Please remember, first one as Cartesian, LLL. Cylindrical, second one LRL. The third one spherical, it is LRR. The fourth one square, it will be RRR. Please remember, so that I have taken in this similar direction. LLL, LRL, LRR, RRR. The first one was LLL, linear along the x direction, linear along the y direction, linear along the z direction. And here it is LRL. Okay, and LLR also you can say, LLR. Okay, and linear along the x direction, linear along the y direction, and other one will be rotational. It may be any one of them. One rotational and two linears will be there. Please do not get confused. And the work volume generated by these robots will be in the form of a cylinder, so that these are called cylindrical robots. Since it is involving one rotational joint and two linear, it can be able to slightly flexibly, it can be able to do complicated job as compared to the Cartesian coordinate robot. So that these will be used for along with loading and unloading and a pick and place. It can be able to do simple jobs like a simple machine, simple painting and simple welding operations. It can be able to do. Okay, it can be able to do. This is about the robot. Okay, 2L and 1R. Now let me come to the spherical or polar robot. Spherical or polar robot will be having one linear joint and two rotational joint. One linear and two rotational joint. And the work volume generated by these robots will be in the form of a segment of a sphere. You take a ball and cut down some portion of it, that will be the work volume defined by this robot. Okay, and since this is having two rotational and one linear, and it can able to do complicated job as compared to the cylindrical and Cartesian coordinate robot. So here it can able to do a painting operation and it can able to do the welding operation along with the previous pick and place and the machine loading and unloading operations. Okay, and here the coordinates of this will be r theta phi. Two rotational will be there, theta phi I have taken. The first one is the coordinate will be x, y, z, a linear, linear, linear. The second one is r theta L, that means linear, rotational, linear. The third one spherical is linear, rotational, rotational. L, R, R. that is 2 rotational and 1 linear. So that means to say it can able to perform slightly complicated job as compared to the previous cylindrical and the Cartesian robots. Now let me come to the giant arm articulated robot. Giant arm articulated robot may be vertical SCARA or horizontal SCARA. If this particular arm is horizontal, that will be called as horizontal SCARA. If this arm is vertical, arm is vertical, it can be called as vertical SCARA. It resembles to the human arm. You can see here, this will be like shoulder, it will be knee, it will be wrist end. Okay, it will be resembles to the human arm, so that it is called as articulated robot arm. Articulated robot arm, and it will be having all the rotations joints. So 0 linear and 3 rotational. Rotation along the x direction, rotation along the y direction, rotation along the z direction. And the work volume generated by this robot will be very, very complicated, and it doesn't have the defined shape of the work volume. It doesn't have. The first one, it was having a rectangular shape. The third one has having a cylindrical shape. The third one was having a segment of a sphere. The fourth one doesn't have proper shape at all. It will be very, very complicated because all the 3 joints will be rotational. And this robot can able to perform whatever the complex job it is. If this robot cannot do any program or any function, the remaining 3 cannot do them. Okay, these are the 4 important physical configurations of the robot. And now I have made some list here. You can see them. Explain the